Okay, example 26. Given that A equals 12, B equals 6, and C equals 7, use Heron's formula to find the area of the triangle ABC. A is 12. B is 6. C is 7. So in order to do Heron's formula, what you're going to have to do first is you're going to have to add 12 and 6 and 7, and then divide all of that by 2. Alpha y equals enter. Okay, I have 25/2. You can leave it as a fraction. You can convert it to a decimal. It doesn't matter. So that is 25/2. Okay, we've taken care of the first part of Heron's formula. Now what you're going to do, we're going to do 25/2 times 25/2 minus one of the side lengths of the triangle times 25/2 minus one of the other side lengths. And then 25/2 minus the remaining side length. You have seen it, but I think it was unit 2 or 3. It's just been a long time. So anyway, I would plug this into my calculator exactly how I have it written on my screen here. And if you do that correctly, you'd get 14.95, rounded to 2 decimal places. I think it was unit 2 or unit 3 when we did that, and we didn't do very many of them.
Why are we starting on that page? You say why?
Say that again.
You say why we're starting on the second page? Bro. Listen, Josh, I missed it. Okay, I'm at. Okay.
Okay, 26B. Given a triangle with A equals 57. B equals 75. And angle C is 30 degrees. Find the area. Let me make you aware of the fact that I don't think it's going to tell you on your next test which formula you're going to need to use. You're going to be given a formula chart, but it's up to you to figure out which ones you're going to need to use to solve this one. This one we have to use sine in order to solve this. It is 1/2 times one of the side lengths times one of the other side lengths times sine of the given angle. Plug it into your calculator, find the area. If you do that correctly, you get 1226.02. On 27 through 32, I believe that is a review of unit 5 stuff. We have cotangent of x times secant of x. Usually if you see cotangent of x, whenever we're trying to simplify, if we're trying to solve, that's a little bit different, but when we're trying to simplify, you're going to want to switch it to its quotient identity, which is cosine of x over sine of x. And we want to change that to the reciprocal identity, which would be 1 over cosine of x. Now, if we multiply, or I'm sorry, before we multiply, we can cross cancel. Then if we multiplied, we get 1 over sine of x, which simplifies to cosecant of x. That's the final answer.
What unit would you say is covering most of this stuff? You know?
Oh my goodness, that's a good question. I really don't know.
It's okay.
If I knew, I would definitely tell you, but I have no idea.
I had a million questions.
This parenthesis here, 1 minus sine squared of x, that's part of a Pythagorean identity. That identity that is sine squared of x plus cosine squared of x equals 1. If I were to subtract sine squared of x from both sides of the equal sign, that would leave me with cosine squared of x equals 1 minus sine squared of x. See? Same thing. This is equal to cosine squared of x. So that's what I want to change this parenthesis to. Change that to cosine squared of x. I'm going to bring down secant of x. Okay, let's leave cosine squared of x. Let's leave that cosine squared of x. We're going to change secant of x to its reciprocal identity, which is 1 over cosine of x. If we multiply, that is what we would get, which would then reduce to i.e. cosine of x. Now, the next example that we have is tangent squared of x minus secant squared of x. What number is that? 29. Okay, this was one of the old cheat sheets that we had on unit 5. Notice that this right here almost matches this one. Except here, tangent is positive, here it's negative. Here, secant is negative, and here secant is positive. Well, in this format, it's equal to 1. If everything is flipped, what do you think it's equal to? Negative 1. That's your answer. Very good. Sine of x times secant of x. Usually, if you see sine or cosine, leave it alone, don't change it. So let's leave this sine of x. Reciprocals, you almost always want to change to its reciprocal identity, which would be 1 over cosine of x. If we multiply this out, we get sine of x over cosine of x, which is a quotient identity. That's the same thing as tangent of x. Final answer. As I mentioned previously, keep sine and cosine the same. You almost never want to change those. Let's change this to its reciprocal identity, which is 1 over sine of x. Multiply those together. 1. You're right. You got the final answer. Good job. That would be sine of x over sine of x. Anything divided by itself is 1. Final answer. And then for 32, it's sine squared of x plus cosine squared of x. Here's where that is right here. It's 1. Very good. Sine squared of x plus cosine squared of x is equal to 1. That's your answer. 1. Okay, 33. Sine of x is equal to root 2 over 2. There's really not much to solve for here because we're solving for sine of x. And what we're solving for more specifically is where in our unit circle do we have a sine value of positive root 2 over 2? There is where sine is positive root 2 over 2. That occurs at pi over 4 radians. And then we have another sine value of positive root 2 over 2 here. That's at 3 pi over 4 radians. So your final answer, pi over 4, 3 pi over 4. Okay, looking at example 34, before I start solving this one, look at examples 27 through 32. In those examples, we changed cotangent to cosine over sine.
Yeah.
We changed secant to 1 over cosine, right? If there's no equal sign, if they're telling you just to simplify, you're probably gonna have to change some trig functions around.
Mm-hmm.
If we have an equal sign, we don't really change trig signs at all. Sometimes maybe at the end, but at the beginning, we rarely want to do that. So here, it looks like we have two terms, both of them have sine of x in common, so we're gonna factor out sine of x. Now, when we factor out sine of x, what we're doing is we're pretty much dividing away a sine of x from both of these terms. So here, that would leave us with the square root of 3 plus here, that would leave us with cotangent of x. We now have two factors, this and this. Sine of x is fully factored, so we could go ahead and set that equal to 0 and then ask ourselves, where in the unit circle do we have a sine value of 0? Do you remember? That's one of them. Pi and
I am,
0. Okay, now let's go over here to root 3 plus cotangent of x. Set it equal to 0. And now we have to subtract root 3. Subtract root 3. Cotangent of x is equal to negative root 3. Now that we've gotten here, you might be thinking to yourself, cotangent of x, where in the unit circle is cotangent of x negative root 3? Now you're going to want to do reciprocals. Okay, the reciprocal of cotangent is tangent. And the reciprocal of negative root 3 would be negative 1 over root 3. You are right. Good. Rationalize the denominator. 1 times root 3 over root 3 times root 3. Tangent of x equals negative root 3 over 3. Where in the unit circle do we have a tangent value of negative root 3 over 3? That would be
30.
the 30-degree angles. The pi over 6 family. There you go. More specifically, 5 pi over 6 radians and 11 pi over 6. So we have 4 answers here. These in pink, and then those right there circled. Example 35, I'm gonna get rid of the cosines and factor this basic trinomial. We need the factors of -2 that subtract to get -1. There they are. We have a leading coefficient of 1, therefore we can jump straight to factored form. If we were to set each of these factors equal to 0 and solve, we would get x equals -1, x equals +2. And now write your trig function in front of them, cosine of x. Cosine of x. So where in the unit circle do we have a cosine value of -1?
That's. No, it's.
Pi, there you go. Pi. And we don't have a cosine value of 2 in our unit circle, so don't worry about that one. Recording. Okay, here, let's add 1. Divide by 2. Where in the unit circle do we have a cosine value of 1/2? Close. Close. Flip that 9 upside down. 60 degrees. That's a 6-degree or pi over 3 family. So pi over 3, where else?
4 pi.
Close.
2 pi.
5 pi over 3. Very close. Pi over 3 and 5 pi over 3. Example 39. State the domain and range and then graph the following equations. I'm gonna write domain and range over to the side because I'm probably gonna forget about that if I don't. Range, domain's pretty easy. Your domain for cosine and sine functions are all real numbers or negative infinity, positive infinity. And we'll wait and do the range in just a moment. Okay. Whenever we're graphing cosine waves or sine waves, both of them have a very identifiable pattern. For cosine waves, that pattern is up, middle, down, middle, up. Let's see if you remember. Is it going to stay that way for this particular function? Why not? Very good. Because there's a reflection, there's a negative in front. Awesome. So if we have a reflection in front, your arrows are going to switch directions. So down, middle, up, middle, down. And I'm going to scratch that pattern out so I don't confuse myself and graph the wrong one. Let's see here. We have a +1 to the right of our parentheses. So that means we have a vertical shift up 1. And that is also going to serve as our midline. We would then look in front of cosine to see what our amplitude is. We have -1 in front of our cosine. Our amplitude is 1. So that means from the midline, you could go up 1 box, draw the top bumper. From the midline, go down 1 box, draw the bottom bumper. Now, inside the parentheses, we do not have any phase shift left or right. So what that means is our graph is going to start on the y-axis somewhere. We just now look for the pattern to tell us exactly where. It's going to start at the bottom bumper first. Then 2 boxes over, it's going to be at the midline. 2 boxes over, top of bumper. 2 boxes over, midline. 1 box over, bottom bumper, and we have now completed a full cosine cycle. If you wanted to fill in the remainder of the graph, one way you could do it is start from right to left and follow the pattern. Down, middle, up, middle, down, middle, up, middle, down. I'm going to show you 2 ways to find your range. If you're able to graph or look at a graph, that's the easiest. Just look at where your top and bottom bumpers would be. So this is going through the y-axis at 0. And it's going through the y-axis at 2. Now, what if we don't have a graph? What if it just gives us a function and tells us to find the range? What you do is note what your vertical shift is. In this case, it's 1. And you're going to add that to the a value, which is just the number in front of your trig function. So 1 plus -1. That would be 0. And then do 1 minus -1, which would be 2. So there's 2 different ways you can find your range. Example 40, we're about to graph a sine wave. The pattern for a sine wave. Middle, up, middle, down, middle. Then we would have completed a full cycle. Is our period here going to be 2 pi? No. What is it going to be? You know? 4 pi. Well, you're close. Did somebody say pi? It's going to be pi. Very good. Very good. So the way that you take note of a period change is see if you have anything in front of x. This is an example, by the way, of one of those formulas that will not be given to you on your next test. It's not going to show you how to solve for the new period. It's 2 pi over b, and your b value is the number in front of x. So we have a period of pi, meaning once I complete a sine wave, mid, up, mid, down, mid, once I get to that portion, we should be at pi radians. Okay, let's start graphing. We have a vertical shift of 1. So go up 1. And we have an amplitude of 1 yet again. There is no phase shift. There's no shift left or right. So we're going to start on the y-axis. We're gonna start at our midline. Now, usually, we go midline, 2 boxes up, 2 boxes, midline, 2 boxes down, right? But since we've had a period change, we're only gonna shift over 1 box. So 1 box to the right, up. 1 box to the right, mid, 1 box to the right, down, 1 box to the right, mid. And just keep following that pattern. And for the sake of time, I'm not even gonna worry about graphing the other side. Don't worry about it. 41, 2 times cosine of x minus 1. Here's the pattern. Up, middle, down, middle, up. We have a vertical shift down 1. That's our midline. Amplitude of 2, so we're going to go 2 boxes up. Graph the top bumper. 2 boxes down from the midline. Graph the bottom bumper. We are going to start on the y-axis at our top bumper. Up, middle, down, middle, up. That one's done. Example 42. In what quadrant is sine of theta less than 0 and tangent of theta greater than 0? I would draw this graph right here, and then all students take calculus. Now you could be right. In fact, I think you're right. Very good. Did you say 3? Yeah, you're right. Good job. Here's what they're asking. Where is sine negative? Well, not here and not there. Sine is negative in these 2 quadrants. Where is tangent positive? Here, not there. So your answer is quadrant 3. That is the quadrant where sine is negative and tangent is positive. Find the component form, magnitude, and direction of vector v. It's really already given you the components for this one. This is a review from the last unit. In order to find the magnitude, you're going to take the square roots of your x term, square that, and the square root of your y term, and square that. Since this is a review, I'm going to let you plug that in on your own. I'm not going to do that. But if you do it correctly, you should get 4.472. Yes.
You don't have to try to see if you like.
No. Correct. For direction, we are in quadrant 3. So that means whatever answer we get for theta, we're going to have to add 180 degrees to that. So one way you could do it is just do 180 plus, you could do this in your calculator, just how I'm writing it here. Inverse tangent of y divided by x. If you do it correctly, you would get an answer of 206.565 degrees. All stuff we covered last unit. (44) Find the component form of the sum of u and v with directions, angles, blah, blah, blah. Okay, I'm going to do this part first. Magnitude cosine 20 magnitude sine 20. And we're gonna add that to the component vector. 3 cosine 150. Sine 150. And that would give you your resultant vector. If you add these correctly, here's what you would get. Your x term would be 3.040. Your y would be 3.552. Pop quiz. It doesn't ask you this, but I'm just curious. What quadrant would this fall in? Quadrant 1, very good. You'd have to go right 3.4 units, you have to go up 3.552, that's quadrant 1. And lastly, 45, given these component vectors, find 2 times vector u. So 2 times 5, these are pretty easy, just distribute. 10. That's your first answer. Now they want you to add component vector u with component vector v. Make sure you add x terms with x terms, 2 plus 0. And then y terms with y terms, 5 plus -4. Go ahead.
Is it, okay, 35 plus -4, not -4 plus 5.
Right. Yes. And then lastly, -3 times component vector v. Distribute -3 times 0. -3 times negative. And you're done.